Assalamu alaikum, guys. This is Mohammed Yashuddin. Today I'll discuss about environment chemistry. Okay, the guys, we just look at the whiteboard and given some equations. Okay, which are very related to this environment chemistry numerical problem only. Okay, the guys, first which I given, that is PV equal to P1 V1 plus P2 V2. Okay, the guys, yeah, it is a total pressure. B is a total volume. B is total volume, and P1 is pressure of any element. V1 is pressure of any gas, and P2 is the pressure of a second gas, uh, and P2 is the volume of second. Okay, this is actually fast gas related, and this is second gas related. Okay, when they combined, then the total pressure and total volume you have to consider. Okay, there guys, just from this formula we can find out the pressure, total pressure, total volume. Anyway, if a question gives us P1, V1, P2, V2, and total volume V, we can find out the total pressure here guys. And actually, each question gives us V1, V2. That means total volume we will get by adding V1 and V2. Okay? That means if question gives us pressure P1, P2, and then we can't do that normally by addition. Okay? We have to do this by this formula. If we put this formula, if we apply this formula, then we can find out the total pressure. PV equal to P1 V1 plus P2 V2. Okay, these are partial pressure. Okay, PV equal to nRT. The rest is very important formula for finding out the actually molecular mass. Okay, by finding out the molecular mass, we consider the Graham's formula, that means diffusion rate. Okay, if we get the molecular mass of any gas, then we can find out the diffusion rate of that molecule of that gas. Okay, that is, that's why we have to remember this formula. And N is the mole number. N here is mole number. We can write mole number by like this: M over capital M. R is a molar gas constant. Molar gas constant, molar gas constant. Its value is 0.0821 liter atom per Kelvin per mole. There guys, try to remember this unit: liter, then atom, then Kelvin per Kelvin. That is inverse minus one, mole per mole. Okay, liter and atom per Kelvin per mole, and the value is 0.0821. 0.0821. You have to remember this magnitude for doing the mathematics. Okay, molar gas constant 0.0821 liter atom per Kelvin per mole. Okay, when we consider the volume unit liter, then we will get this molar constant, this value 0.0821. But when we consider the volume liter, then what will be the molar gas constant? Then molar gas constant magnitude would be 8.31. Okay. Anyway, there guys, and that means total formula PV equal to nRT. Small n over capital M. RT, T here temperature. P is pressure, V is volume, N is molar number. Okay, N is molar number, and we can write down molar number like this. In here, small n here, the amount of gas, which question gives us. Okay, and capital M is the molecular gas, molecular mass. Sorry, molecular mass of an molecular mass. Capital M. Okay, and P here pressure, V is volume. P here pressure, V is volume. If question gives us P, V, small m, R, T, then we can find out the molecular mass. Okay, that is PV equal to nRT equal to small m over capital nRT. Here, this formula R1 over R2 equal to root into over M1. Actually, here we need by the R1, R2 diffusion rate. It's actually we have meant the diffusion rate of any first gaseous element of diffusion rate. R2 is the diffusion rate of the second gas. It equal to root into means molecular mass of second gas and molecular mass of first gas. Okay? Just by this formula, we can consider which one has more diffusion rate or less diffusion rate. Suppose if question gives M2 M1, okay, then we can compare the diffusion rate between two gases. Okay, R1 R2 equal to root into. There is another formula P1 V1 P1 V1 over T1 P2 V2 over T2 because actually this is actually our temperature, pressure, and volume related formula, and Boyle's law, Charles law combined formula. This is actually Boyle's and Charles law. From those two laws, this formula we have got. If question gives us P1, B1, T1, P2, T2, then we can find out B2. If question gives us access to find out T2, okay, and given the value P2, V2, P1, B1, T1, then you can find out the T2. Actually, we have to know more than 5 quantity. Okay, and then you can find out the remaining quantity. There, guys. Again, I said P1, P1 over T1 equal to P2, V2 over T2. Okay, if you get the value uh, T2, P2, V2, P1, P1, then you can find out T1. Actually, for finding on the unknown value, we have to know the others quantities value. Okay, there guys. This is another formula P1 over T1 equal to P2 over T2. Noted on this P1 over T1 equal to P2 over P1, actually pressure of any fast gas. Okay, P2 is another gas pressure, and T1 temperature of fast gas or temperature. T2 is temperature of second gas. Or actually P1 over T1 equal to P2 over T2. P1 over T1 equal to P2 over T2. If question gives us T1, P2, T2, then we can find out P1. If question gives us P1, T1, T1, then find out P2 from this formula. Okay, there guys, another formula PD equal to capital N over capital N A. It's RT. We have written this N, but we have now put this value N over capital N A. A is the Avogadro number. Try to remember A is the Avogadro number, and which is 6.02 to 10 to the 6.02 to 10 to the. Oh, N is the number of molecule. N is the number of molecule. Oh, sometimes we question to find out the number of molecule, or sometimes question asks you find out the temperature. Anyway, this very important formula. We have to know what is P, what is B, what is N, what is N A. R, R is a molar gas constant, which is 0.0821 liter atom per Kelvin per mole. Okay, and B is volume, N is the number of molecules, N A is the Avogadro number, R is molar gas constant, T is temperature. Okay, and if question gives us P, B, N, A, R, T, then we can find out the number of molecules. So N over N A R T. Another formula P1 V1 equal to P2, which is very known formula to everybody. P1 pressure of fast gas, V1 pressure of second gas, P2 is pressure of second gas of second state, B2 is volume of second state. Second. You can find out actually any required quantity. Suppose question gives you P1 V1 V2, then you can find out P2. Suppose a question asks you to find out B2, then question give you P1 V1 P2, you can find out P2. Actually, from this formula, you can find out the unknown value. P is the kinetic energy, total kinetic energy. Kinetic energy because 3 2 nRT. Try to remember 3, 2, nRT. Any mole number R is a molar gas constant is the temperature to the time angle. C which is root mean square velocity. Root mean square velocity. Root 3p rho. 3p rho. 3p is pressure, rho is density. Right? Okay, C equal to root 3p rho. Here, pressure at STP, one atom, 1 lakh, 1325 Pascal. 300 Pascal. Try to remember this. And 1,325 Pascal. 1,325 Pascal STP pressure at STP on atom, or you can write down this Pascal pressure at STP. STP standard temperature pressure 1 ATP, or you can write down 1,325 Pascal. Okay, there is again I say in short, PV equal to P1, V1 plus P2, V2, PV equal to nRT equal to small m over capital N, RT, R1 over RT equal to root M2 over A1, P1, V1 over T1 equal to P2, V2 over T2, P1 over T1 equal to P2 over T2, PV equal to capital N over capital N capital A, RT is a molar gas constant is equal to 0.0821 liter atom per Kelvin per mole. Number of molecules is number of molecules. And A is another number which 6.0 to 10 to the 2. Okay, P1 V1 equal to P2 V2, and pressure at STP equal to 1 ATM equal to 1 lakh 1,325 Pascal. P equal to 3 over 2 nRT. C equal to root 3p over rho. That is, if you can remember this formula, and then you can understand any type of numerical problem related to environment and T. And if you practice a lot of creative question and read from your books and solve your question and do a lot of numerical problem, then you can realize the application of this equation. Okay, and so on.